Excellent. So now we are going to take the bias out of econometrics.
Okay.
Yes, we are. Duo Chin, SOAS, University of London. Over to you.
Thank you. And I should really... sorry.
Forward, backward.
Oh,
And if you want to point something, the red one.
Right, thank you, thank you. It's really, thanks Victor for kind of sincerely invite me. And this is really a methodology paper, has nothing to do with financial innovation and anything. And it's not forward-looking, it's slightly backward-looking. Because as you can see, that my real finance paper was joint work with Sophie, and so Sophie has done it. So now I'm trying to use a very short period of time to talk through this genuinely methodology paper. However, I would assume over 90% of people sitting here are trained economists. What I can try and contribute here is to tell you, don't believe endogeneity bias that you taught from undergrads. You will be freed of this concept. Move forward, really. And so, so I hope this would be my contribution here for the next 20 minutes. It's an issue which kind of confused all of us for over 60 years. And it took me a long, long time to try to think through, and also took me quite a bit of courage to try to write a paper, because I was thinking, what the hell, I'm going to retire very soon. I'm not famous, I'm okay. I don't mind making a fool of myself, so I might dig into it. Okay, so that's my kind of initial thing. But I do hope what I'm going to illustrate here for quite a few years of thinking through the issue can persuade you to believe that the endogeneity bias is a conceptual trap. You don't need thinking about it. Now, the issue, there are bits, because I know it's a quite short period I'm allocated at that, so I just try to delete some of the slides, and because it's published, and unfortunately the bits that I deleted seem to be most relevant here, because I delete most of the selection bias and the program evaluation bits, because I thought it's more micro. So I misunderstood this financial kind of, anyway, but basically, I know it's quite late afternoon, but you have all done economics degrees, or most of you, so you all are very familiar with how endogeneity bias is kind of taught through your boring econometrics courses, okay? And it becomes such a fundamental issue that everybody is scared. I know just now it's kind of, whenever you talk about something endogenous, you're worried about the bias. Don't worry, because it's almost not there, okay? The reason it's not there is that because the issue has been extended to such a fundamental issue from all different reasons. It started from simultaneous equations, so you have all done the simultaneous equation and proof identification and the bias, and all the rest of the bias, and then extended to all other issues, because it becomes such a paranoid, so everybody was thinking about. And when I think now the concept is more bothering to micro people than macro people, because we get over it, and I'll explain why we get over it. But basically, you learn that you need to worry about this bias because you regress your key causal variables might be endogenous, then the consequences of that endogeneity is going to be correlated with the error term, and then you need to try to make sure to clean this. So all the issues, be it omitted variable bias, missing controlled variables, or selection bias, or program evaluation, it might be a different group, then the problem is there. However, when you think about the whole way of thinking about this issue, it's really anti-scientific way. Because I did my PhD in history of econometrics. So it started all from simultaneous equation. So all the textbook you learn is two equations, then you can prove, you can show from the mathematics that the regressor is correlated with the error term, right? So that's all from there. But when you think about it, it's a phenomena, just like a fever. And then you think it might occur in selection bias, so you need to clean it. So as if it's a phenomena of correlation. Whether you have a flu, or you get a virus, or you have infection, or you may have a cancer, whatever, since you have a fever, just trying to get over the fever, then it's done. So it's just really very anti-scientific research that from different causes, you're trying to cure the phenomena. That's what you learn. And fundamentally, if you cure the phenomena, the problem is not there. The causes are so very different, we do the other way around from what we should have done, which go for the causes, right? But even worse, if you have a fever because you get the virus or you get infection or something, you actually find the fever. For this kind of bias, we have no direct evidence. Okay? Because this bias is not within sample bias. It's going into the convergence, which is totally global. It has nothing to do with the error term of your sample, because you know when you use OLS, it's unbiased within sample. So what you're talking about is a kind of hypothetical error term would be correlated hypothetically out of your sample, but we don't have the correlation. Nobody provides you the correlation. Okay? So unlike in medical case, you can have a fever when you have a virus, or you have an infection, or you have a cold or flu. Here, nobody's seen the correlation. We can never measure the correlation because, by argument, it's beyond the sample evidence, right? So it's extremely weird when you think about it, that all the different causes, you forget about it, cure the correlation which we don't even have direct evidence. Okay? So what I first look in, sorry? Any, yeah. Yeah, almost. Let me tell you. Okay, so the only issue is because the first thing I look into is how to interpret the IV, because the cure is to use a kind of instrument to orthogonalize the assumed bias, then you are safe. But there are so many problems. Over decades, people argue about IV. So so I'm trying to, first of all, what I look into is trying to see what is the nature of IV, why people argue. Some people really love IV and some people really hate them. So I'm trying to explain what they are here. So basically what I'm trying to explain is from the origin, which is the simultaneous equation, and which is that in all your textbooks you learn where the bias started. So it's from a simultaneous model. You know you have two models, and then two equations in the model. Then we are told that if you look one equation use all or less, that you know that this x supposed to be correlated, can be correlated because your original model is simultaneous, is over there, right? The only problem, and you all know that that's not identifiable with that two equations. So what you do is you kind of bring in some so-called exogenous instruments to use IV so that you can get rid of the so-called bias. So that's all textbook stuff. But this IV really comes from what we call the measurement error. And the method originally was invented to cure so-called measurement error, nothing to do with the simultaneity equation. So basically, in the measurement error, that means you have latent variable. Just now we were talking about latent variable. And then whatever you observed is approximate measure, so it's a measure with errors. So if you have measurement error in the observed variable, one of the approach is to use some instrument if you have to filter out this error. So you smooth out this error to create an x hat, which is supposedly to be a latent variable. Okay, so that's the idea. So basically, if you can find a set of instruments and clean the error terms out, then you get a more kind of refined measure of your latent variable. Okay, so basically, if you think about this root, sorry, I'm just trying. The simultaneous equation idea is the grand idea from Hovermore that all the variables are random variables, they are joint determined, whereas in the probability theory, if they are jointly determined, then you can decompose them into a conditional bit and a marginal bit. So the essence of this is if they are joint determined, you are not supposedly, you cannot go down the conditional route because the conditioning being invalid, it's endogenous. Basically, it's rejecting the direct conditioning, okay, in terms of probability. So the conditioning bit is wrong. They only allow you to be simultaneously. So that's the probability behind the scene. But what happened is that in the measurement, in the measurement error literature is you can't, because of you have measurement error for a latent variable, you can't do direct conditioning. However, if you clean the error, then you can do the conditioning, okay? So that's what the essence. So behind the scene, then the whole idea from measurement error has been translated into the IV treatment of simultaneous equation. So basically, you are not allowed directly conditioning on X. You have to use a set of exogenous variable to clean the so-called endogenous X. Then after the clean, then the conditioning become this, right? So you're not allowed, so direct condition because it's endogenous. But after IV, you create a new X hat, which it becomes the valid conditioning. So that's how the two-stage least square means. So basically, when you look at the two-stage least square formula, the essence of this is you have to generate a new X, which is substantially different from the old X, and that is your new causal variable, and that is the valid conditioning variable. So you have to really change your key causal variable because you are actually rejecting the hypothesis X is a valid conditional variable for Y. So you reject direct causal inference, and then you have to create some kind of a new X, which is like a compound weighted by all the instruments. And your target is that when you do this instrumental, the second stage, you're not supposed to do a good job. And that is what Hausman test is about. If the fit is very close, defeat the purpose. It's also the X. So the essence of the estimation is nothing but rejecting your X to be a valid causal variable. You have to do a very poor fit in the first stage so that you create a new causal variable, and that is different from the X, and that will let you pass the Hausman test. And the better you fit, it defeats the purpose. Okay? So that's the whole idea. Do we have evidence here? All of you have done all the macro time series, realize, no, we actually have no empirical support for this. Because the whole the time series macro modeling has moved down all the VAR, rational expectation terms. So even though you have a whole set of simultaneous equations, because dynamically you fit all on the lags, what happened is that by fitting a whole set of models over time series, even though your X is endogenous, which meaning that it's modeled variable, the fitting of the X is getting higher and higher closer to the original X. So that's why endogenous bias is no longer a problem for macro time series. And this is a theorem, actually, original proof by Hermann Walls over 50 years ago, because he proved mathematically if your residual is more or less white, then the endogeneity bias is not a bias. And when you think about it, you can have all your variables endogenized so long as they are causal. If you put all their lags time in there, even within the model, the so-called endogenous variables getting a better fit. So the resulting X hat is closer to original X, and therefore IV is no problem. The bias are out. Yeah, exactly. Because you are fitting all the variables closer, and also because actually economists are correct in saying that X should cause Y, rather than you do a huge compound of different variables to dilute that original causal variable, the evidence is appalling. And that's why in macro, time series people, endogeneity bias is no longer an issue, okay? So mostly the evidence is whatever endogenous, if you have multi-equation set, that more of evidence support the original causal rather than IV generated model, okay? So that there's no evidence to support a kind of IV generated alternative for the causal substitute. I think, yeah. Here I did some diagrams called the direct accredited graphs. These graphs I put in here is, I don't know whether some of you use them. They are very kind of popular because of some kind of machine learning behind. However, as long as the published diagrams are concerned, I think their diagram over the IV is incorrect because I've seen many diagrams about IV. So that here I kind of trying to create my own IV diagram to show why it is incorrect. Because what happened with the IV model is it's not extending the chain. So the IVs are not allowed to go into the model. Basically, their only function is to help to generate an alternative causal variable. That's all. So they're not. So that's why there's a lot of debates over IV. They don't have official meaning, but behind the scene, they're trying to substitute away your crucial causing variable by something which is distinctly or statistically different to create different estimates. That's all it is. So basically, I've drawn my kind of new causal diagram to show how IV trying to cut the original variables into a different shape so that your key causal variable has been changed. Okay? Rather than the variable being incorporated or extend your causal chain, because by definition, you all know that IVs the instruments shouldn't have any causal interpretation. It only helps you trying to clean the bias. Okay. Shall I? Oh, 1 minute. Probably I shouldn't go into the omitted variable bias, but basically the omitted variable bias is another way of saying that you should trying to clean, or IV rather is trying to use to clean the bias. It's actually closer to micro issue because when you have a huge micro data set, you're always worried about that there are other variables that you haven't considered, so they might affect, and the other variables are unobservable. So the argument is, if you have potentially unobserved Z, and then potentially you might have endogenous bias. So what you're advised to do is to find a set of IVs which are supposedly to be orthogonal to the unobserved potentially correlated variables and use those to try to use the IVs to estimate rather than use OLS, then the bias, you can avoid the bias. Okay, so they have all the definitions. But basically, what happened behind is here, what I try to draw. Because the omitted variable bias is this case, so you have some Z you're worried about that might be correlated with the X, and so that cause the omitted variable bias. But here, there are two possibilities you try. One is that the Z have no direct effect to Y. Its effect only through X. That is very, very rare, almost non-existent in economics, right? So the only other simplification is this. If you have a lot of other omitted variables, so long as they do not have bias, then we are safe. Especially for micro, we're only trying to explain what we are interested in, one or two causal factors, but not others, so long as they're not correlated. So what the IV tries to do is that if we only have case 1, but we're trying to use IV to change the X to make it orthogonalize, then we are safe. So basically, behind the scene, the IV is trying to, again, use to change the definition of your causal variable to make it more orthogonal. A lot of double difference technique is just there, because originally you are interested in X versus explain how much X explain Y. But you know X might be correlated. So you change into difference of X versus difference of Y, because the more difference you feel more safe. However, quite a lot of times, the effects between difference variables is very different from the effects between level variables. So again, you modify your original hypothesis in order to avoid the correlation. But then the cost is you have to modify the original causal hypothesis. There's no way to orthogonalize without changing the meaning of your causal variables. So a lot of times in this context, you actually modify your original hypothesis in order to avoid the potential correlation. Yeah, so what I was trying to draw is that if you have case 1, the only way to get out of it is to try to reconstruct your X via IV to avoid the correlation, but the cost is you have to revise your causal variables. And the meaning of your model might be changed. It's actually changed because it's not the original causal, okay? So again, the conditioning is that you have to modify your causal variables. And if you still interpret as the original hypothesis, there's inconsistency. So now, when you think about this, there is such a kind of conceptual confusion in this whole story, because we econometricians come with the new term of endogenous regressors. As a kind of historian, I try to chase who's come with this term, and then I stopped because I don't want to attack any living. Right. So I'm not going to tell you where I chased, but when you think about it, all the first-rate econometricians, they are such a brilliant mathematicians, and their proofs have no internal inconsistency. But when they link these two terms, it's a void. This is an empty set, because endogenous means reject conditioning, and regressor means conditional. So endogenous regressors, this term has a void. It's a zero set of variables. Right? You can't combine the two terms together. But as I said, the bottom line of the problem is that in econometrics, I think we confused our understanding of what the error term is. And after writing this paper, I kind of realized that in machine learning, they kind of differentiate two notions of error term. One is within the training sample error term. The training sample error term is within sample error term. And that error term is known unknown, because by choosing any estimator, we generate the error term. So we say it's unknown. That means there's no causal, but by choosing the estimation method, that's how you separate data into the error term. So the error term is known unknown because you generate it. Whereas the generalization error term, which is what the endogeneity bias is about, it's totally unknown. Okay? Because it's out of sample. You can't control its generation process, so you don't really know it. So if it's unknown, how can you prove the correlation? The only way to prove the correlation is that you think the original model is 100% correct when you give a simple model. And sometimes it's even harder to think. In the omitted variable bias, you know your model suffer from omitted variable bias. Instead of trying to correct the cause, you're still trying to remove the imagined symptom again. And then the end result is that actually your original causal variable has been modified. Okay, so the whole idea is to prove there's a bias, especially the bias is beyond sample bias, is a too early closure of your hypothetical model. And so
I'm going to plead with you since time is moving, if you
Okay.
can put your last slide on.
Okay, this kind of thing is called type 3 error. That means the question you started is incorrect question, and all the proofs afterwards are all correct. Okay? So it's a wrong question to pose this. And the other interesting bit relating to machine learning understanding is that the generalization error actually can be decomposed by two parts, whereas the bias part actually comes from the choice of the theory. It has nothing to do with estimation method. And unless you assume your model is 100% correct, you cannot identify the bias to the estimation method. Okay, right. So that's historically. I'm trying to show that why.
So I'm going to have to.
So
I
let me
think
just stop.
we've actually already finished the discussion time too. So,
So I stop. Yeah.
all right, big round of applause. Okay, so I'm going to take only one burning question, okay? Because we're at the very end. Okay, one burning question, and that'll be it.
Okay, well, yeah, thank you very much for this very impressive presentation. Well, as a macroeconomist, I'm a little bit worried. If you allow me, and we've known each other for so long that I'm sure you're going to allow me. Well, so long means 25 years. Yeah. So my impression as a macroeconomist is that you are fighting the last war. I said you would have to forgive me. So. Because as macroeconomists, we have learned maybe, well, several decades ago that agents are forward-looking. So when I write a macroeconomic model, I'm rather going to feed in some expectation, T+1 variables, and then I'm going to use GMM to try and instrument this expectation at of a T+1 variable. So would it be possible for you to address this pressing issue for macroeconomists rather than maybe the other one, which maybe does not interest us that much anymore? I mean, our agents are forward-looking. This is a problem. Maybe I should refer to the, well, possibly Guryeru causal, non-causal models, if you see what I mean. Some variables are driven more by what happens in the future than by what happens in the past. So could you tackle this also? Sorry.
I think this is beyond. I need to see the model, okay? So again, it's beyond the endogeneity of these framework, but depends on where your information comes from, the future information. Again, I think it's beyond this framework.
So that looks like something you can use your 25 years of relationship to. Maybe you can talk after this. So a big round of applause for our speaker, please.